We are going to continue talking about trig, but we are going to move into looking at graphs of trig functions. I'm going to show you tangent first, and then we actually aren't really going to focus on tangent. We're going to focus mainly on sine and cosine. But just so you can see what the graph of tangent looks like, because it's a little bit different. So here's the graph of tangent of x. And so what we see is infinitely many, so these go on forever and ever, copies or repeats of the same little line here. It has an x-intercept, and then the first one happens here at 0, 0. The next one happens at pi. And then the next one happens at 2 pi, and then 3 pi, and this one over here is at negative pi. So it has x-intercepts at every multiple of pi, and then it has these breaks. So those actually don't connect to each other. They are broken. So remember when we have that line that breaks up a graph, and it's an up-down line, so a vertical line that breaks up a graph, we call that an asymptote. So it has these vertical asymptotes that happen, and they happen exactly in the middle of these. So it happens at pi halves, or a half of pi, and then repeatedly on at all those multiples. So that's what the graph of tangent looks like. It is repetitious. We call that periodic when it does the same thing over and over and over. Kind of like in a normal school day, you have your 7-period day and you go through that same schedule every day over and over and over. It's periodic. You do the same thing. So that's what the graph of tangent looks like. We are actually going to focus on sine and cosine. So here's the graph of sine. It is also periodic in that it does the same thing over and over and over and over. So it has an x-intercept right at the origin. Okay? So sine goes through the origin, and then it follows a pattern of going up, back through the midline, down, and back through the midline. And then it repeats that pattern. Up, middle, down, middle, up, middle, down, middle, up, middle, down, and it keeps on doing that same pattern over and over and over. So it's also very symmetrical in going through its period or its cycle. So 2 pi is the length that it takes for us to get one full set of a sine graph. Right in the middle, that's pi. And then we have our up point here in the middle of that at a half a pi, and down here at 3 halves of pi, or 1.5 pi. Okay, we're going to focus more on that periodic nature in the next lesson. Actually, what we're going to focus on today is where is this midline and the amplitude, or how tall is the graph. So this graph has an amplitude of 1. That's the height from the midline up to its high point. Okay? So it has an amplitude of 1. That's how tall it is from middle to top. And its midline is right at the x-axis there. Now, if we switch over and look at cosine, cosine goes through that same wave, except it starts in a different spot. It starts in its up spot. So it goes up, midline, down, midline, and then back up. So up, middle, down, middle, up. But it still has that same midline here, and the amplitude is still the distance from that midline up to the high point. So that amplitude is 1. Okay? Now we can adjust this function. Let's say that I did 3 sine of x. Okay, well, what change did that make to it? It made it taller. Well, how tall is it now? The height from our midline, which is still here at 0, up to our high point is 3. So our amplitude is 3. All right. We could also take this graph and let's say move it up a little bit. So now the midline is actually right here. So in some of your problems, you're going to be asked to find the midline. Now, we'll hold off on looking at that equation for a second and just say, if we were only given the graph, how could we find the midline here? Well, first thing we'd want to do is find our high point. And on Khan Academy, they're going to be labeled for you. So that high point has a y value of 4.2. And then you might be given your mid point, or you might be given your low point. Let's say we're given our low point. So our low point here is at negative 1.8. Right? So we're looking at the y values there because today in today's lesson we're going to only be talking about the midline and the amplitude. So we're talking about height, which is a y value. So we're not looking at those x values today. We'll take that in the next lesson. But today we're going to look at those y values there. And so as we look at those y values, a high of 4.2 and a low of negative 1.8. From that, what we want to do is find our midline and find the amplitude of this function. So let's see if it'll let me start writing it. All right, so that was a high point that was at 4.2 and a low point that was at negative 1.8. Okay, so let's say that from that I wanted to find the amplitude. Well, let's say this point's up here at 4.2, and then our next one, this low point's down here at negative 1.8. Well, the distance between those cut in half should be our amplitude. The high and the low, and then exactly in the middle of that should be where the midline is, and then the amplitude is the distance from that midline up to the high point. So what we want to do is figure out, well, how far apart are those 2 points, or what is the difference between those two numbers? So if I do 4.2 minus 1.8, well, minus a negative, I'm really adding there, so that's going to make a 6 is the total difference between those 2 points. The amplitude then must be 3. Half of that difference between the 2 points is our amplitude. So our amplitude is equal to 3. Another question you could be asked is, where is the midline? Well, if we know the amplitude, it should be a midline distance away from either one of those points. So we could either take the 4.2 and subtract 3, or we could take negative 1.8 and add 3 to move up to this midline. And so if I do 4.2 minus 3, I get 1.2. Or same, if I do negative 1.8 plus a 3, I should also get 1.2. So our midline would be at y equals 1.2, a positive 1.2. Another way to find those from the two numbers is to think about, well, what word do we usually use for the idea of middle in math? Well, if I want to find the middle of two numbers, what I want to do is find the average of those two numbers. So to find an average, I add together the two values and divide by 2. And if I add together those two values and divide by 2, I should get 1.2. So our amplitude is half of the difference between the high and the low. So difference, we're going to subtract them. Be careful about minus and negative, okay? But we're going to subtract our two values. That finds our total difference between them. Cut that difference in half, and that gives us then our amplitude. If we want to find the midline, we could either subtract that amplitude from the high or add it to the low, or we could take the average of the high or the low. So a couple of different strategies there for how to find the amplitude and the midline. You might, in some problems, instead of being given the high and the low, let's say that we are given a graph of, let's say, let's say we're given a graph that looks something like this, and let's see. I want to make it plot our midline value for us there, and it's not wanting to do that. Okay, maybe I'll change it to, now it'll give us our midline value. Okay, so because this is a sine graph, here's our midline value. So our midline value is 3.1, and our low value is 1.7. Okay, so in this problem, let's say we were given our midline and our low. Let's say those are the 2 points that we are given on our graph. So a middle value of 3.1 and a low value of 1.7. Well, in this problem, if I wanted to find amplitude, then it's just going to be the difference between those two values. So I can just subtract those two values. And let's see if I can just drag this on up and give myself a little room to write here at the bottom. So on this one, if I want to find the amplitude, I can just take the difference of 3.1 minus 1.7. And I didn't bring my calculator in here. And you guys know arithmetic is not my strong suit. Okay, so I just subtracted that. And I got 1.4. Okay, so that would be our amplitude then. The difference between our middle and either the high or the low, because that should be the same because it's middle, right? So that is our amplitude value here. And our midline, well, we just know our midline because it's already provided for us by having that midline value of 3.1. Okay? So that's how you can find them from the graph. So we're looking at amplitude is half the distance between high and low, or it is the distance between the middle and either the high or the low. And then that midline is the line that contains those middle values, which would be our average of high and low. Well, what about from an equation? So that's if you're given a graph. What about if you're given an equation? Well, in this problem, our amplitude was 1.4. Where do you see that in the equation? Well, it's right here, right? 1.4. It's a negative. What that did is it took the graph and it flipped it upside down. So if I take that negative out of there, it doesn't change the size of the graph. It just changes whether it goes up or down first. So the amplitude is 1.4. That's the height. And our midline was 3.1. Well, where do we see 3.1 in the equation? Right here. Okay, so let's say that I gave you a problem that was like 8.2 cosine of, and you know what, there could actually be like all kinds of crazy stuff in here. And we'll go minus. Okay, whoa. This is kind of a crazier graph, right? So what about the values now? What would we have? Well, our amplitude is still going to be this number out front, 8.2. And that amplitude is going to be the difference between our midline and the high or low points. What is the midline? Well, that's going to be this number right here, minus 2.6. So if I graph y equals negative 2.6, that blue line is now the midline of this graph. So here is a middle point, okay? It has a y value of negative 2.6. Here's a high point. It has a value of 5.6. So if we take the difference between the middle and the high, then we should be able to find our amplitude. Okay, so if I do 5.6 minus negative 2.6, so I wish those points would have stayed there. 5.6 was a high point, minus negative 2.6 was our middle point. We get 8.2, which is the amplitude. So that again, here was our middle point at negative 2.6, and here was our high point at 5.6. Okay, so that would be our amplitude. Or on this problem, you could as well be given that high and low, and then have to take that difference and cut it in half. Okay, but from our equation, this number out in front is our A, that's our amplitude value, and this number at the end is our midline, including its sign. But if this number out front is negative, we still say the amplitude is positive, okay? So even if this was negative 8.2, we still say the amplitude is 8.2. because amplitude is height, and height is always a positive direction. Okay, so amplitude always positive. Make sure you always type in a positive for amplitude. Your midline could be a negative number. It takes that negative sign with it if it has one. Don't worry about this mess inside of here today. That's going to be for our next lesson, what that mess inside of there does. Okay, so you're going to have a couple of Khan Academies about this. Some you'll be given the graph and asked for amplitude or midline, and some you'll be given the equation and asked for them. So let me know what questions you have as you're working through those assignments, and I will see you guys again soon.